fundamental research has been carried on. But first of all, I would like to remind us that light, of course, was not, has been at the center of the interest of humanity from the beginning. The religions, the myths, the philosophical ideas have all started by consideration about light or about the sun, which is the source of light. You can see on this fresco how the light beams are going from the sun to the eyes of this observer, who is either a goddess or a princess, and in a way which is a kind of premonition of what the 20th century has taught to us. The light is made of discrete bunches which are now called photons, but of course this was just an idea at that time. So the first questions about light were answered by myths, by religions, or by philosophy, but this had nothing to do with the scientific process, with the scientific mind of today. The first scientific answers about light came much later. In fact, as we will see, at the beginning of the 17th century. Why are we celebrating this year the International Year of Light? As I said, it is the anniversary, round number anniversary of many events. The first one occurred much before this the time of science of the 16th century. In the year 1015, that is 1,000 years ago, the Arab scholar Al-Hazen, working in Baghdad, wrote the first treatise of optics, describing the propagation of light rays. And he was the first to say clearly that the light was not going from the eye to the object, but from the object into the eye, and the eye was a receptor of the light. Then we had to wait, according to these anniversaries, 800 years. 200 years ago, the French physicist Fresnel, through experiments, found that light was in fact a wave, and a transverse wave. That is a wave which is oscillating in a direction which is perpendicular to its propagation, like waves at the surface of a pond or surface of water, for instance. Then 50 years later, and this is a very important year, in 1865, Maxwell found that light was in fact an electromagnetic phenomenon, the propagation in space of electric and magnetic fields together. And this was really a breakthrough, which is at the origin of all modern technologies, using light or electromagnetic waves. It was also essential for theoretical physics. It is by looking at the symmetries of Maxwell's equation, about what Maxwell's equations were hiding from us, that Einstein was led to the idea that time and space were two intertwined concepts, that it was impossible to speak about space without time, and that mass and energy were also related, and this led to the theory of special, then general theory of relativity. And the year 1915, 100 years ago, Einstein developed his final ideas and theory of general relativity, which is the basis of all cosmology and all knowledge about the universe. But this is not all. In 1965, 50 years ago, two engineers working at Bell Labs, Penzias and Wilson, discovered by chance, without looking for it, the cosmological background radiation, the fact that all space is permeated by microwaves, which are the remnants of very strong light fields which were produced 400,000 years after the Big Bang, when matter and light separated. And this cosmological background is now detected by satellites like the COBE or the Planck satellite. And here you can see in false colors the tiny fluctuations of this radiation, which shows that the universe is not uniform, that there are fluctuations which are quantum in their origin, and which explain how galaxies were formed in the region where the density of matter was a little bit higher. So this background radiation is very important for cosmology. Again, 50 years ago, when the laser started, an engineer, Charles Cao, who is from Hong Kong, and I think still living in Hong Kong, developed the first transparent fibers, which are combined to lasers and are used to transport information around the world, and it is the basis of the internet, of the global communication network. So these years are very important, but of course you cannot reduce the history of light to round number anniversaries, and there are many other events which are important. And as I said, the story started really in the 1600s. The 1600s have seen the first quantitative observation about light phenomena, and also the development of the first modern optical instruments by combining lenses. And it was a time where someone like Spinoza was polishing lenses in Amsterdam. By combining lenses together, the first microscope and the first telescopes were built, which initiated the exploration of the infinitely small and infinitely large worlds. But what was light? In fact, two essential questions were raised at that time. Is light made of particles, or is it a wave phenomenon? According to Newton, light was made of a flow of particles, and each color corresponded to particles of a different kind. According to Huygens, the Dutch physicist, on the other hand, light was a wave, like a wave at the surface of a pond, and the color was related to the wavelength of the light. And of course, there was at that time no way to distinguish, but both point of view, of course, implied that light was propagating at a finite velocity, which was not so obvious. There are a lot of philosophers and medieval philosophers who thought that light was all at the same time, that light was permeating all space without propagation. And so the second question was, is it instantaneous or does it propagate at a finite velocity? And the story of the velocity of light, how you measure it and what it implies, is a leading thread to all this physics.